Welcome to this video on the final year project. We are covering a practical roadmap for taking your project from an initial idea all the way to deployment. We'll explore how to balance classic software engineering with modern AI-assisted tools to streamline your process. A final year project is a capstone effort where you design, build, and defend a complete solution to a real-world problem. It is a critical milestone that integrates everything you have learned in your BSCS degree, from database design to software engineering and communication. Why does this project matter? Beyond being a graduation requirement, it is the most important piece of your portfolio. It provides you with tangible industry exposure, helps develop research skills, opens up future job opportunities, and can even serve as the foundation for your own startup. A strong project yields significant returns. It serves as concrete proof of your technical abilities for employers, helps you secure quality internships, offers a reusable codebase for freelancing, and provides the experience needed to build a professional product. To succeed, avoid these common traps: starting too late, poor planning without milestones, submitting generic copy-paste tutorials, neglecting documentation, and failing to perform thorough testing before your demo. These issues are easy to identify and can significantly impact your evaluation. There are many types of projects you can undertake. Whether it is a web or mobile application, an AI or machine learning system, an IoT device, or a full-scale SaaS product, ensure your choice aligns with your interests and the scope of the assignment. When choosing your project, evaluate 5 key factors: your personal interest, market demand, the expertise of your team, the availability of necessary resources, and the potential for future scalability. This video follows an 8-stage life cycle, starting with your idea and moving through research, documentation, design, development, testing, deployment, and finally, your presentation. This process serves as the backbone for your successful completion. Documentation is essential proof that your work is deliberate. It guides your development, helps your supervisor evaluate your progress, and acts as the primary source for your final report. Key documents include the SRS, SDD, and various UML diagrams. The Software Requirements Specification, or SRS, is your contract. It defines what your system must do. It categorizes requirements into functional, such as search capabilities, and non-functional, such as performance and security. User requirements add context by focusing on the user's perspective. The Software Design Document, or SDD, outlines how the system is built. It details your architecture, modules, database schema, and overall system design. For example, a layered architecture separates your user interface, application logic, and data storage. Solid database design is crucial. Start with diagrams to visualize entities and their relationships. Once the model is clear, translate those into tables with appropriate keys and ensure you normalize your data to prevent redundancy. UML diagrams provide the visual contracts for your project. Use case diagrams map user interactions. Activity diagrams show process flow. Sequence diagrams detail object communication over time, and class diagrams define your system structure. To stay on track, establish clear milestones and use sprint planning to manage your work in 1 to 2 week blocks. Break your modules into small, estimable tasks and use a Kanban board to track your progress across the semester. Finally, embrace an AI-powered workflow. While AI tools cannot replace fundamental engineering knowledge, they significantly compress development time, allowing you to focus on high-level architecture and testing, which remain essential to your success. Let's look at the toolkit for this project. We'll use tools like Claude and Claude Code for reasoning and generating full-stack code. For faster in-editor iteration, we rely on GitHub Copilot and Cursor. Google Stitch is our go-to for rapid UI design, while Anti-Gravity and ChatGPT help with scaffolding and brainstorming. Design your UI/UX efficiently with Google Stitch. Start by describing your screen in plain text, then use the generated variants to refine your prototype. Once you pick the best layout, you can export it as a reference and hand it off to Claude Code to generate the actual components. For backend development, Claude Code is a powerful assistant for API generation, database integration, and authentication. Always write a master prompt first that includes your SRS and SDD context. This provides a clear specification, leading to far more accurate and reusable code than asking isolated questions. Your front-end development workflow should focus on modularity. Using React, break your interface into small, self-contained, and testable components. Use routing to map your URLs correctly And manage shared data using standard practices like state management. Keep your project organized with a clean folder structure. Separate your backend, front-end, and documentation into distinct top-level folders. Group features into modular sub-apps. Keep your docs alongside your code for visibility, and never commit secrets. Use environment files and a shared example template instead. Version control is mandatory. Use Git and GitHub to maintain small, meaningful commit snapshots. Utilize branches to isolate new features or experiments without affecting the main codebase. This clean history serves as verifiable proof of your work, which is a huge advantage for your portfolio. The testing phase is where you ensure quality. Perform unit testing for individual components, integration testing to confirm modules work together, and user acceptance testing with real users. Finally, run security checks to protect against common vulnerabilities before you consider the project complete. When you are ready to go live, use hosting platforms like Vercel or Netlify for your front-end and Render or Railway for your back-end services. Ensure your database is deployed securely and set up monitoring to track logs and uptime so you can address issues quickly. Documenting your journey is as important as the code. Follow your university's formatting guidelines strictly for your final report. Include clear, labeled screenshots of your features and ensure all references are cited consistently, whether you use IEEE or APA style. For your final presentation or Viva, keep your slides visual and concise. Rehearse your live demo end-to-end, and always have a backup video recording ready. When answering questions, know your weakest module the best, as that is likely where the committee will focus. Industry recruiters look for more than just a project that works. They check for clean, readable code, an active commit history, evidence of automated testing, and a live, deployed link. These markers demonstrate professional engineering maturity. Your final project can even evolve into a startup. If your work solves a real-world problem, you have a head start. Validate your niche by talking to users, implement multi-tenancy to support multiple customers, and focus on direct outreach to start selling your solution. To summarize the entire process, start with your SRS, move into research and UI design, then build your backend and frontend. Integrate testing, deploy your application, finalize your written report, and finally, prepare for your Viva. This complete path ensures you cover every base. As key takeaways, remember, start early, document rigorously, use AI deliberately, test relentlessly, and think beyond graduation. Your FYP is not just a requirement. It is a platform for your future career, whether as a software engineer or an entrepreneur. Thank you for watching. Every expert was once a beginner who refused to give up. Use this project to prove your capabilities, and remember that this is just the beginning of your professional journey. Please reach out if you have any further questions.